Okay, y'all. Welcome to the first part of transforming bacteria with plasmid. And so what I want to do with this video is set up where we left off after lab number 7 and talk about kind of the front matter, what you're supposed to be doing to get this lab started. I encourage you to read through the protocol, so don't just skip to the videos, don't just skip to the questions. Read through the protocol and carefully consider what it would feel like to do these different steps. It's the best we can do given the circumstances. So, all right, so I've got behind me a sketch of the different plasmids that we were using. So if you remember way back before we started spring break, we had the pAMP plasmid and the pCAN plasmid. Both of those plasmids have a resistance gene. So pAMP has the ampicillin resistance gene, and pCAN has the kanamycin resistance gene. And so each of these would be expected to provide resistance to a bacteria that carries, or bacterium that carries that plasmid. And so a bacterium that's carrying the pAMP plasmid would be protected against the ampicillin antibiotic, and a bacteria that carries the pCAN plasmid would be protected against the kanamycin antibiotic. And so what we did is we digested both of those with BAMH1 and HindE3, and those should have made cuts in each of the plasmids. And the idea here is that after digestion, we ended up with all of these different products. What we're hoping to do as an end game is we're hoping to assemble a plasmid that has both the ampicillin resistance gene and the kanamycin resistance gene present. And so when we finished our digestions, this fragment had BAMH1, this fragment had BAMH1, this one had HindE3. And so those are sticky ends. They can come together, and these sticky ends don't care whether they're sticking back to the place where they originally came from or to some other place with a similar BAMH1 or HindE3. So these aren't labeled, but this is BAMH1 here, BAMH1 here, and these are each HindE3. So those sticky ends can come together, and we added ligase. The ligase is going to repair the phosphodiester linkage, so when this is all done, we should have a plasmid where those sticky ends are covalently bonded to one another. So if you remember, we left our ligations at room temperature for several hours. We left them overnight. And so when you came into this lab, you had a tube with different ligation. You have a tube with your ligation mixture in it. So you have one tube with your ligation mixture already present. And so what we're trying to do today is we're trying to take our plasmid and we're trying to insert it into bacteria. And so before we can insert plasmid into bacteria, we first need to make that bacteria competent to accept the plasmid. And so the beginning of this lab, you would come in and there would be cells that are growing. They're happy, healthy cells. So there's plenty of nutrients available. They're in the process of expanding. We call this mid-log, the mid-log phase of growth. We'll talk a little bit more about that in lecture, but the idea is we're catching them before they start to hit a high level of density. So they're happy, healthy, reproductive. And so what you would do is you would aseptically transfer cells. So using sterile technique, you would transfer cells out of that culture where they're in the mid-log state, and you would transfer them to a tube. And so if you were here, you would have a tube that looks something like this. No, I'm sorry. You would have a tube that looks something like this. We would put this tube with your cells in it into the clinical centrifuge. We would spin it at relatively slow speed. That would collect the cells at the bottom, and there would be media left in the tube. We would then dump the media out, and we would add some cold calcium chloride to those cells. We would flick to resuspend the cells. Sometimes this pellet's a little bit tricky, so we might have to use the vortexer to get the cells back into solution. So we've got cold calcium chloride on our cells now. We're going to incubate them for a short period of time, and then we're going to put them back in the clinical centrifuge to spin them down and collect them again. This time, we're going to resuspend with cold calcium chloride, but we're going to do a smaller volume of cold calcium chloride. the whole idea here is that the calcium chloride is making those cells competent to accept the plasmid. So we've included another video below that I think does a better job of going through and explaining what's happening on a molecular level with these competent cells. They've got some pipe cleaners and visuals that I think help make this more clear than I could with a chalkboard. And so I'll refer you to that video that explains both the process of making cells competent using cold calcium chloride and also the process of heat shocking the bacteria so that they take up the plasmid. So I'll see you all on the other side of that. Thanks.